This is lessons 8.2 and 8.3. Today we'll be proving triangle similarity by AA, SSS, and SAS. So we've seen most of those letter combinations before when we talk about triangle congruence. Now we're going to talk about triangle similarity. So for AA triangle similarity, if two corresponding angles are congruent, then the triangles are similar. Make this a little bigger. So in my first picture, I have an angle that's 75 and an angle that's 24 here, and 75 and 31. So right now, I do know that I have two angles that match, or I should say a single angle that matches, but I don't know what the third angle is in each of them. So let's say I added together 75 and 74, and I got 149, and I take that away from 180. I found out my last angle is 31 degrees. And now that's a second angle that matches. So these two triangles are similar by AA. All right, similar by AA. And a similarity statement is when we say triangle, and now we'll say ABC is similar to triangle. So A was the 75, so B was the 74, and then, all right, in the second picture, I have these angles, V and Y are already congruent, and I also have vertical angles that are congruent. So these are also similar by AA. So we could say triangle VXW is similar to, so V had 1, Y has 1, X, Z. The second method that's possible is side-side-side, or SSS similarity. If all corresponding sides are proportional, then the triangles are similar. When I'm comparing two triangles, I'm going to identify the smallest side of one and find the smallest side of the other, and I'm going to put them in one kind of notation. I'm going to take the biggest side and match it with the biggest side, and then the middle with the middle. So I'm using different symbols to identify what sides go together. So now when I make my fractions, 3 over 6, 5 over 10, and 4 over 8, I'm going to see if all three of these are the same thing. So 3 over 6 is 1 half, 5 over 10 is 1 half, 4 over 8 is 1 half. So all of the ratios are equal, meaning the sides are proportional. So this is similar by SSS. And my similarity statement, so I could call it PQR. And now P was between my circle and triangle, so circle triangle is S. Q was between circle square, between circle square is P, and then we have U. All right, we would do the same thing on this bottom one. The smallest of these three sides is 30. The smallest of these three sides is 24. The biggest is 35. The biggest is 28. And then the middle is 32. The middle is 25. So 30 over 24. 35 over 28. 32 over 25. So 30 over 24, I can divide that by 6, is 5 over 4. 35 over 28, I can divide by 7, that's 5 over 4. But 32 over 25, I can't reduce. There's nothing that goes into both. And if I get 1.28. And each of these would have been 1.25, right? 5 over 4 is 1.25. This is 1.25. This is 1.28. So since all three fractions are not the same, not similar. And our last method of triangle similarity is SAS, side angle side. So this is where we have two pairs of proportional sides and the angle between them is congruent. So in the first one here, we have an angle here and an angle here. So we do know we have one of the angles. And now I'm going to look at the two sides that make up that angle. The smaller one is 8, the smaller one is 6, the bigger one is 20, the bigger one is 15. So 8 over 6, 20 over 15, that's 4 over 3, that's 4 over 3. So yes, This is similar by SAS, triangle JKL, and triangle MNP. All right, this last one is the trickiest one here. So I generally will redraw if my pictures overlap with each other. And if I look at this triangle ADE and triangle ABC, both of them had angle A. So that's like a reflexive or shared angle in the two shapes. So one of the triangles has a side of 15, a side of 12, and this angle here. And then the bigger one has the angle there. That's point B, point C, point A. And now this whole side is 25. This whole side is 21. So of these two, 12 is the smaller, 21 is the smaller, 15 is the bigger, 25 is the bigger. So let's say we did 12 over 21 and 15 over 25. So here if I divide by 3, that's 4 over 7. Here if I divide by 5, that's 3 over 5. So this is not similar. So even though I had what looked like side angle side, the sides were not proportional, so the triangles are not similar. So for all the next examples and check-ins, we're going to determine if the triangles are similar. If so, explain how and write a similarity statement. So here, I know I have a right angle involved, so that matches so far. But then I have two rectangles, so I'm going to find the third angle in one of them. So let's say I divide 64 and take that away from 80. I get 26 degrees from my missing angle here. And now I do, in fact, have two pairs. So similar by AA. And we could say triangle BCE is similar to triangle. So I started with right angle, I went to the 26, and then my next. All right, next example. I have two separate triangles. So like I said before, anytime I have overlapping triangles, I'm going to redraw them. And anytime the triangles overlap like this, we're going to have this top angle in common. So I actually do have two angles that match. I have the one that was reflexive, and I have another angle that's 52 degrees. So this is also similar by AA. And I could say triangle ABE is similar to triangle ACD. All right, another example. Here I have vertical angles, which I can mark right away. And if you recall, when we have these markings here, they're parallel lines, which means alternate interior angles are congruent. So these and these. So even though I have three angles matching in that, I'm still only going to say similar by AA. Right? We don't have an AAA, just AA. And we could say triangle VSR is similar to triangle VUT. All right, last example here. So I have 21 and 99. I get 120, meaning my last angle here is 60 degrees. And here, 21 and 61, add up to 82, and take that away from 80, we get 98 degrees. So we only have one angle that's congruent, the other two don't match. So this is not similar. All right, I believe there's two check-ins for you to try. Yep. So let's put both of them up on the screen for you. All right, go ahead, give this a try. Pause when you're ready to see the answer, hit play. All right, so for check-in number one, both triangles are equiangular, so all angles actually match in both of them, which also means our similarity statement could have been anything, because every single angle in one matches with every single angle in the other. So even if you did not have FGH matching with QRS, if you had anything, you're right. For our second one, I actually redrew them separately, and I found the missing angles. So I had a missing angle of 58 degrees up here. I had a missing angle of 32 degrees right here. So we did in fact have at least two matching angles. So that's similar by AA. And I had triangle FCD is similar to triangle FDE. Right, and the next example, I have vertical angles that are and now 12 and 6 of 24 and 48, 24 is smaller, and then 12 is bigger, 48 is bigger. So I'm going to compare 24 to 6, and I can compare 48 to 12. So this reduces to 4, this reduces to 4, that's equal. So these are similar by SAS. So the triangle FEG. So notice I started on the side with a congruent angle and circle. Congruent angle, circle, RE. All right, next one. I have two triangles with right angles in them. So I can compare this one and this one. So if I were to redraw that, all right. So around the right angle, I'm going to look at 12 is smaller, 9 is smaller, 16 is bigger, 12 is bigger. So we're going to compare 12 to 9 and 16 to 12. So 12 over 9 is 4 over 3. 16 over 12 is 4 over 3. So we do, in fact, have similar triangles, similar by SAS. If I wanted to also compare 20 to 15, I instead could have actually used, right, 4 over 3, similar by SSS. So there's actually two possible answers for this one. All right, and I'm going to make my similarity statement. So I'm going to put X, Z, W, X, Y, Z. So let's say triangle XZW is similar to triangle. So let's say starting at X on the side with the circle, starting at Y, the side with the circle, and we went to the right angle, and then the last letter. So you're going to try the next two. Get them both on the screen again for you. So pause when you're ready to see the answer, hit play. All right, for check-in number 3, comparing big to big and small to small, both of them reduced to 4/3 or 3/4 if you had major fractions the other way. So this is similar by SAS, and its triangle SRT is similar to triangle PNQ. And for the second one, I separated them. So I have the bigger side of 15 to the bigger side of 45. I got 45 by adding together 30 and 15. The smaller side of 14 to the smaller side of 42, which I got by adding 14 and 28. Both of those reduced to 1/3, and we had our reflexive included angle. They are similar by side angle side, and I got triangle WQR is similar to triangle WSZ. So in example 7, is either DEF or GHJ similar to triangle ABC? Identify the smallest in every single triangle. I'd identify the biggest in every single triangle. And then the middle in every triangle. So we're comparing both of them to ABC. So either this or this is similar to this. And what I'm actually going to check really quickly is A, B, C, and G says, notice 8 is 8, 16 is 16, but 12 is 10. So I already know all two factors are not the same, so I can eliminate this two. So now I'm going to check this one. I'm going to go 8 over 6, 12 over 9, and 16 over 12. Oops, that's 20. So this is 4 thirds, this is 4 thirds, this is 4 thirds. So yes, so we can say triangle ABC is similar to triangle DEF. So in this next one, determine if the two triangles given are similar. If so, explain how and write a similarity statement. Pause. When you're ready to see the answer, hit play. All right, comparing biggest to biggest, middle to middle, smallest to smallest, we end up with 2.3 repeating if we divide them, or 7/3 if we reduce them. So they are in fact similar by side, 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 and I ended up with triangle GFH is similar to triangle DCE. So now we're going to use some applications here. A flagpole casts a shadow that is 18 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest tenth of a foot? I have actually created two triangles here, and both of them have a right angle, because we're going to assume both the person and the flagpole are standing up at right angles. In addition to that, because the sun is only one sun on Earth, and we're standing relatively close together, the angle formed by the sun will be the same. So these triangles are similar by AA. We know that the flagpole's shadow is 18 feet. The woman's shadow is 40 inches. The woman is 5 feet 4 inches tall. So 5 feet times 12 inches in a foot is 60 inches. Plus 4 more inches is 64 inches. So that's the woman's height. And we don't know the flagpole's height, but because its shadow was measured in feet, we could assume the flagpole's height will be measured in feet. So it's okay that these are different units, because I have the same 2 units in this figure and the same 2 in this one. So as long as they match in that way, then I'm okay. So I'm going to compare 64 to X, right? Height to height. And then I'm going to compare 40 with the shadow to 18. So when I cross multiply here, right, remember cross multiply, the butterfly method, we're going to get 40x equals, I'm going to do 64 times 18, and I get 1152, which when divided by 40 gives me 28.8. So the flagpole is actually 28.8 feet. So you're going to try the next one. So just a reminder, the flagpole was 28.8 feet. Its shadow was, I forget, 18 feet. Also, the woman was 64 inches, and her shadow was 40 inches. So you could use either of those to now find the length of the child's shadow when the child is 58 inches tall. Pause when you're ready to see the answer, hit play. So I actually used the woman's triangle. So I had her height is 64, her shadow is 40 inches, the child's height is 58 inches, the child's shadow is X inches. So 64 over 58 equaled 40 over X. And when I cross multiply, I get x is 36.25. It asks how long is it to the nearest inch, so that's 36 inches. Right, last ones. So we want to find the value of x that makes so AB matches with DE, BC matches with EF, and that's all I need. As long as I have x involved, I can solve for that by sending these two pairs of sides. So 4 over 12 equals x minus 1 over 18. Cross multiply here. It's 12 times all of x minus 1 equals 18. So that's 12x minus 12 equals, I think that's 72. Add 12, so 12x equals 84, and 84 divided by 12 is 7. So 7 will make those triangles similar. So you're going to try the last one. Use the similarity statement to find the value of x that makes the triangle similar. Pause. When you're ready to see the answer, hit play. All right, so I chose to use the 30 with the x minus 5 and the 15 with the 3. I didn't need the 5 times x minus 6 or the 5. So when I cross multiplied, 15 times all of x minus 5 equals 30 times 3, I ended up with x equals 11. And that is everything from 8.2 and 8.3, proving triangles similar using AA, SAS, and SSS.